All right, everyone, let's dive right in. Today, we're tackling a huge topic for any developer: modern backend architecture. We're going to go on a journey, starting with the good old monolith, moving into the world of microservices, and giving you a real playbook to help you make the right calls for your next project. Let's get to it. So, picture this. You've got a fantastic idea, you're fired up, and you're ready to start coding. You open up your editor, and then that huge question hits you. How am I actually going to structure this thing? Believe me, this one decision right at the start can pretty much define your project's future. So, to help you figure this out, we've got a clear roadmap. We'll kick things off with the monolith, then figure out when microservices make sense. We'll talk API tech, how to fix latency, scale your database, and then we'll wrap it all up in a final playbook you can take with you. First up, the monolith. Now, I know what some of you might be thinking, isn't that kind of old-fashioned? Not at all. In fact, it's often the absolute smartest, most strategic way to start a new project. So why start with a monolith? Well, it really just comes down to speed and simplicity. With a monolith, you can launch fast. Your DevOps needs are low, which makes it perfect when you've got a small team, say 1 to 5 developers. Microservices, on the other hand, have a ton of setup overhead and really demand a bigger team from day one. The takeaway here is simple. If you want to ship fast with a small crew, the monolith is your best friend. But what happens when things go right? Your project is a success, it's growing, and that's when you start to feel some, well, growing pains. And those are the signals that it might be time to think about microservices. So, what do these signs look like in the real world? Well, deployments start to feel super risky, and they take forever. Your dev teams start stepping on each other's toes, blocking progress, and you start to realize that one tiny part of your app, maybe the payment service, needs way more resources than everything else. You need to scale things independently. These aren't just little annoyances, They're huge flags telling you it's time to evolve. So what exactly are microservices? The concept's actually pretty simple. You take one giant application and you break it into a bunch of smaller, independent services. The best analogy is a restaurant. You have one team just for taking orders, another team for cooking, and a third for handling the bills. If the billing system goes down for a minute, the kitchen can keep on cooking. That, in a nutshell, is the core idea: resilience and independence. Okay, so you did it. You split your monolith into services. Awesome. But now you have a totally new challenge. How do all these separate services talk to each other without slowing everything down? This brings us to our next big decision: your API technology. We've basically got 3 main contenders here. You've got REST, which is the universal standard, using text-based JSON. Then there's gRPC. This is the speed demon. It gets its amazing performance from a binary format called protobuf and the newer HTTP/2 protocol. And finally, GraphQL, which also uses JSON, but gives your front-end clients this incredible power to ask for exactly the data they need, no more, no less. But for pure internal speed and type safety, gRPC is the clear winner. Let's make this really actionable. If you're building a public API for other developers to use, just stick with REST. It's the industry standard. Everyone gets it. Now, if you need fast internal communication between your own microservices, you want to choose gRPC for its raw speed. And if you're building a mobile app or a really dynamic front end that needs to grab all sorts of different data, GraphQL is going to be your best bet. Now, we have to talk about the biggest, most common drawback of microservices: network latency. When all your services are making network calls to each other instead of just talking in memory, things can really slow down. But don't worry, this is a totally solvable problem. And just how much does that API choice matter? A lot. Choosing gRPC over REST for your internal service communication can give you a 30 to 50% speed increase. That is a massive performance gain from just one architectural choice. Beyond gRPC, you've got a whole toolkit for fighting latency. You can implement caching with something like Redis to stop making the same calls over and over. You can use asynchronous messaging with Kafka so services aren't just sitting around waiting for a response. You can even denormalize some of your data to avoid really slow cross-service joins. And of course, a simple one: deploy your services physically close to each other in the same data center.
This all leads to what we call the hybrid architecture. It's a pattern used by giants like Netflix and Google. Here's how it works. Your front ends, like your web app or mobile app, talk to a single API gateway using something flexible like REST or GraphQL. That gateway then acts like a smart traffic cop, turning around and talking to all the internal backend services using super fast gRPC. You really get the best of all worlds.
Okay, your services are fast, your architecture is smart, but as you grow, another bottleneck is bound to show up. The database. A single database server can only handle so much traffic before it just gives up. The solution when you get to massive scale is a technique called sharding. All it really means is splitting one giant data collection across multiple servers, or shards. This is what lets you scale horizontally. You can just keep adding more machines to handle more and more data, a load that a single server could never dream of managing. So how do you actually do this? Well, it depends on your database. If you're using MongoDB, good news, sharding features are built right in. For Postgres, the thing to look for is the Cetus extension. And if you're on MySQL, the gold standard is Vitess, which is the system that YouTube famously built to handle their unbelievable scale. We have covered a lot of ground, so let's bring it all together into a final playbook. We'll nail down the key lessons and clear up some really common points of confusion that I hear all the time. This brings us to probably the #1 question developers ask. Should I just start every single new project with microservices right from day one? And the answer is a very clear, very definite no. The smart strategy, the one that will save you so much time and so many headaches, is this. Start Monolith, split later. Say it with me. Start Monolith, split later. Only do it when you actually need to. All right, let's tackle another one. There's so much buzz around GraphQL. A lot of people wonder, hey, can I just use GraphQL and not have to worry about microservices at all? And once again, the answer is a big no. They solve completely different problems. GraphQL is all about how clients get data from your backend. Microservices are about how you structure and organize your backend. They're not competitors. When used together, they're actually powerful allies. So here it is, your final playbook. #1, microservices are powerful, but they are not for every project. 2, always start with a clean, modular monolith and just evolve as you grow. 3, use the right API for the right job. gRPC for the backend, REST or GraphQL for the front. 4, latency is a real problem, but it is totally fixable with the right tools. And finally, sharding is for massive scale. Don't even think about it before you absolutely need it. And that brings us to the end. You now have the principles. You have the playbook. So the final question is for you to think about. The architecture you're building today, yeah, it works. But is it ready for the scale of tomorrow? That's all for now. I'll see you next time.